Hi all. Igor made a great intro and he got a beer. So I want to finish quickly and get another one. Uh, so today I'm going to speak about MySQL Partition Manager, which is actually one thing that we developed in our company to help us uh, to manage some of the problems that we were having with few tables. Before starting, so who am I? My name is Perica Akimov and I work at Flutter CE as a DBA team lead. You might know us as Singular previously, so now we are part of Flutter. Flutter CE is a newly formed region from Flutter Entertainment, which is actually the world's biggest company for online gaming and sports betting and casinos. So which translates to busy systems on our site. Uh, so what will be the agenda for today? I will explain a few things about what is partitioning in MySQL, just as an intro for the ones that didn't had the opportunity to check that. What are the pros and cons of using those? How to implement it if you already don't use it? What is required to manage those partitions? Our internal use case, just as maybe it will give you some hints how you can solve it on your side. How we automated our partition management because it is overwhelming to do that manually. And at the end, I hope we will have some questions. Um, yeah, partitioning in MySQL. So when you talk about partitions, maybe the hint is to partition the disk on multiple partitions and to separate them, to manage them differently on a hard disk. In database world, everybody knows that we are working with tables. Those tables can be also partitioned into multiple logical pieces, which will represent something to us. So that can effectively give us some cons about how we manage those partitions. Um, each partition will hold part of the data from the whole table. It is still seen as one table for the queries, so you don't need to change how the application communicates with the database. Everything remains the same, so all the queries remains the same. Each partition in MySQL is stored as separate physical file, and it actually uh, is like having multiple tables in the background, but they are represented as one big table for the application. Um, to do partitioning, we need to provide the partitioning rule. So there are four rules how we should partition in MySQL. So we need to find a way to tell the MySQL server what we want to do with this data, how we want to split this data. Uh, the partitioning can improve performance for some of the situations, which we have some specific terms here: partition pruning and partition selection. And it makes data management easier for some of the things, like, for example, dropping old data, which was the main reason why we wanted to introduce this in our setup. Here on this picture, we have shown how from non-partition table we can define the partition strategy and uh, convert it into a partition table. So we have a very simple table that holds data for orders. We provide the partition rule which we want to apply, like split this data from this 1 year of orders into 4 partitions. For each partition will hold 1 quarter, calendar quarter of that year as a separate uh, as a separate file in the background, so it will be easier for management. At the end, we have the same orders table now in the background with 4 partitions and 4 physical files on the disk, but presented as one table as it was previously to the application and all the queries that are communicating with the database. Quickly, I will mention all of these partitioning types and when they should be used. The most obvious is the one that I've already shown, the range partitioning type. Here we have some detail statements for example table, uh, and we have this small table. We want to do the partitioning by the order date. uh, the range partitioning actually works with integer numbers. So if you have another data type for the columns, you need to convert it to some kind of an integer. So in this case, we are using today's function to convert the date into integer. And with these specific things that are written here, we are defining the so-called ranges. So for all the values that are less than this date here, we are treating that partition as Q1. The next one, for all the values that are less than this date and bigger than the previous one, it will place all those records into the next partition, and so on. The latest one is maybe the interesting one, because it holds it has something that says max value, which actually represents the highest possible value for the data type that we are working with. So with this extension of the DDL of the command of the table, we are converting this table into partition table. So here we have presented like how uh, the existing records are going to be placed into different partitions in the other side. The next partitioning type is the list partitioning. So similar to the previous one, but we are not defining ranges. We are defining fixed values. So a list of values that we want to define our partition for. So in this example here, we have the store ID as an integer, and we say we want to partition uh, to gather all stores that are from some region, for example, into one partition. So we can define something like this. So these must be fixed values, and it can work only with the values that are provided here in the list. Similarly, like the previous one, it will take that store ID value and know exactly in which partition those records should be placed. Uh, Next one is an extension for this range and column and list uh, partitioning types, which is called columns. It actually extends, like improves the already mentioned ones with uh, bigger set of supported data types. So it is not only integer that is now supported. You can put strings, datetime, timestamp, and it has a simpler way of defining those things. So if you have a datetime column and you specify a range columns, then you can directly specify the column name. You don't need to provide additional functions. And here in the values list for the ranges, you are defining the strings for those dates that you want. So again, no functions are needed. On the other side, we have again a different example for the list columns. Uh, Now we have an example that we are using strings, and list columns, and also these range columns also can work on multiple columns at the same time. So when it compares the values from the records with the partitioning function, it compares tuples to tuples actually. So we can define multiple tuples that will represent some partition, which means something to us, and we want to manage it as a separate entity on the database. And here we have some interesting example what happens when you provide values that are actually not in the list of possible values. If we have that situation, so the record cannot be placed. MySQL cannot know in which partition to place that record. So if that is an insert query, it will fail. If we want to apply the changes on already existing dataset, the alter table will fail. So there is no possibility to guess in which partition it should be if it's not specified here. I will mention just the other two, which are not relevant for the examples that I'm going to share later, but just for you to know that they exist. There is a hash partitioning type, which actually, for which we are not defining lists or ranges, but we just define partitioning function, like hash function, for the column, and we provide the number of partitions that we want to have in the background. So the main purpose of this is to have even data distribution for all the records between multiple partitions. And on there is something similar to the hash partitioning, which is called key partitioning. Very simple, very similar idea as you see. The only thing that is different is the function that is used in the background. So for key partitioning, MySQL is defining its own partitioning, its own algorithm for doing the calculation of the hash in the background, and you can provide the partitioning column on which you want to apply this function, or you can omit it for the key partitioning. If you omit it, it will by default use the primary key of the table. So the end effect is evenly distributed rows between the number of partitions, similar to the hash. This is a slide to just make a quick comparison between all of this. I will not go into details about this. And now, what is partition pruning? So this is a maybe new word for you. It actually means that MySQL automatically skips irrelevant partitions during query execution. So because now we have these partitioning rules defined, MySQL is well aware which records should be placed in which partition. And if it knows how to place them on insert, it can know how to find them later. So uh, if you are searching in the where clause using the column that you used for the partitioning, then it can quickly understand that all the data that you are working for is placed into one partition or maybe two, and it doesn't scan all of them. So we have one example here that says for the orders table that we already had, if we are working for all the orders that have from this date, for example, uh, it understands that these orders records with this order date are all into the partition that is marked like Q2. And if you want to do similar thing, but you wrap up this um, column name into some kind of function, for example, to find all the orders from May this way, then it cannot understand where to find it, and it will scan all the partitions on the table. So for small partitions and small data set, this is maybe not that relevant, but for bigger data sets, this is crucial to have better IO and better performance of the system. Partition selection is another concept that you can explicitly target specific partitions, so it overrides the automatic pruning. So there is a way for you as a user to tell the MySQL server which partition you specifically want to target with some of the queries. So here we have some samples that if we have this kind of table defined, we can select everything from orders from this partition. So you can add partition and one or maybe multiple partitions separated with commas here, and then it forces the system to scan only those partitions because that is what you want. You can do the same concept for delete statements to delete something with some filter only from one partition or multiples. Exactly the same concept for update. And if you want to use it for the insert, it gets interesting because the insert is something that um, is the MySQL server on the insert always knows in which partition to place the new record. So you can use this approach, but if you provide a value that actually cannot be placed into that partition using these rules here, it will fail with an error. So it is not allowed. So there is no actually uh, something positive that you would want to include the specific partition into the insert. Just provide the values that are needed, and MySQL will handle it automatically in the background. Here is some pros and cons about using partitions. So it might look interesting, but I just put here few of the pros and cons that were on my mind. It can have improved query performance via partition pruning for some of the situations. It will not cover all the queries. It can have faster data management because it allows us to drop or truncate partitions instantly, like dropping a table or dropping or truncating a table in the background. So it is a DDL command. It is not a DML command anymore. You have better maintenance for larger tables because you can rebuild a portion of the data if you want to rebuild it or to optimize that partition. It can have improved data organization, so you can logically divide records per something like per date, region, or whatever the logic is on your site. Uh, it can have a potential for parallelism, like because some queries will touch some partitions, some other queries maybe touch in other partitions. There is a possibility for MySQL to do multiple things in parallel because it accesses actually different data files in the background. And now on the other side, we have a few cons, and most important from all of these are the ones listed here. So you seen how the table structure looks like. It is much more complex than we have when we have a standard table, let's say. So more complex design, index limitations. So when you split the data into multiple partitions, the indexes are split into multiple partitions also. Each partition holds its own set of the indexes for that um, uh, data that is held in that partition. So you might experience situations when some queries will need to scan multiple indexes before it finds the correct um, records out of them. Uh, the other thing is now, if you want to introduce partitioning, the primary and unique key constraints must have the partitioning column inside. So if you choose the order date to be the partitioning column, you must provide that column into the primary key. And if you have multiple unique keys, you need to include that column into all the unique keys anymore after that. So after all these changes, the uniqueness of that was specified previously is not true anymore, and you should recheck if everything makes sense after that change. The other big con is also that there is no foreign keys allowed to partition table. So if you partition a table, that table cannot have foreign keys from itself to some other tables, and the opposite from other tables, that it cannot be referenced as foreign key. And as I mentioned, the operational overhead. So managing partitions over time. If you are defining like a fixed number of partitions, like we had in the example with the list column partitioning, maybe you are good, define them all and forget about them. But if you're using the range partitioning by dates or by months, you must maintain these partitions. So you should create a new partition for each new day or each new month and take care of the old ones, because the main goal is to do something with the old data. Uh, how to implement it. So if you see that it actually makes sense for some of the tables in your data model, so how to implement it? As I said, uh, here on the left side, we have one unpartitioned table, like this same orders table. As I said, the primary key here is only ID, and we have some index on the order date in the previous setup, and we have some data inside. So if we want to make it partitioned, we must change the primary key. So in the alter statement, in the alter table statement, we must provide something like drop primary key, adds primary key that will include order date. If we don't do that, it will fail. So you cannot do partitioning. Then you define the type of partitioning that you want and the column and your list of partitions. So this is a list of partitions for year 2026. by month. We have defined one partition that will hold any data which doesn't correspond to any of these defined partitions. Like if you put a record with order date from 2025, it will go into this partition. And on the other side, we have something called like PMAX, which will hold any data that is not part of uh, this partition. So with a bigger value for above the year 2026. So when you execute actually this alter table statement, it will recreate the table. So it will need to rebuild it from scratch because it will now generate a completely new table in the background with 14 data files in the background, and it will read all the data that you have from this table and place it accordingly using the order date value. So for small tables, it can be very quick, but for big tables, you want to plan this accordingly because for few gigabytes or terabytes of data, this might not even be possible to do that if you don't have enough disk space on the system. And when it finishes all the data transfer into the new table, the previous structure of the table is dropped, and from then on you have the new structure. Uh, Now about partition management. So when we define these partitions, we need to manage them. As I said, we would like to create new partitions for new months, and we would like to decide what to do with the previous ones. So we need to add partitions, drop partitions, or maybe truncate some of them. There is an option to rebuild partition. Like if we delete a lot of records from one partition, we might want to reorganize the pages inside to regain some disk space out of it. So there is a concept of rebuilding only a specific partition. There is also possibility to exchange partitions or to move the data from one partition into a completely new table. And this is explained actually here in this example here. So there is a possibility to create a completely new table, which will be a copy of the order table, like copy of from the structure, having all the same columns, the same indexes, but we will after that remove partitioning. So it will be a standard table with the same structure. And we want to move the data from this partition into this new table. So with this concept, with exchange partition, it is only renaming the data files in the background on the file system, and it is updating the metadata of the tables behind the scenes if we use this without validation extension. So actually we can effectively move data from one partition to a table in a matter of few milliseconds instead of copying all the records from this partition into new table, then dropping the old partition. So there are multiple uh, options that will that all of them can be executed very quickly in the background, and it makes the management very efficient. But we have the other problem after that, that if you have a lot of partitions and a lot of tables in the system that are using partitioning, and you have a lot of systems that you observe or monitor or you work with, it is overwhelming to do those. So you need to be careful if you need to, for example, this example is our use case when we have daily partitions. So daily partitions can be overwhelming because you need to manage it day by day or uh, uh, on few days, for example. So we have, in our use case, we had something like tables that are append only, like we are keeping log kind of data inside, like audit history, messages, something that just inserts some content at the end of the in the end of the table, and we want to keep the content, but only for the last X amount of records. So, for example, we have this audit table, and we have partitioned it by day, and we want to put a rule here to say on dev environments keep us only last 5 days of data, on QA keep us 10 days of data, on staging keep us 30 days of data, and on production keep us the last 3 months. So you need to be able to provide that functionality in the background, and that kind of management of the partitions somehow automatically, because you cannot do it manually on multiple systems. Uh, as I said, we are defining different purging or archiving policy. There is a possibility to drop the partition, but some requirements might say don't drop it, move it on some other in some other schema on the same server. So we must keep this data for regulatory purposes, but the application should not be able to access it. So you want to isolate it. We need to have efficient operations. We don't want to deal with uh, insert and delete statements for billions of records every day. So it will be overwhelming for the system to manage those. And for some situations, we wanted to regain disk space because actually we were running low on disk space on that environments. Companies cannot provide the amount of disk space that you wish to have, but you are limited on that. So you need to provide a solution to keep the system alive with the disk space that you have. Uh, we needed to provide daily and monthly partitions for different kind of tables depending on the logic and content that we are using there. And we, as I said, we want to have set and forget design. So you do this once, you set up all the rules, you put the automation in place, and you want to forget about it. And you want to be to have some proper monitoring or alerting in place. So if I have this installed on 10 independent database servers, and each of them manages 10 tables. So I want to be sure that if something goes wrong, I have an alert. If everything goes okay, I'm not bothered with additional information. So this was the main driver for us to take a look into the partitioning. And how did we uh, think when we were planning for automation of partition management? So the first thing, as I already said, define the partition strategy. So do you want to keep partitions daily, weekly, monthly, yearly, whatever we want to do with it? So we need to understand the data set that we are working with and the requirements from the company or from the development team or whoever is using this data. We need to define the retention policy. The policy is just the rules, like keep, I don't know, 10 old partitions, drop the rest or move them into a separate schema, and always keep some amount of new partitions always generated, so you're sure that when the month changes or when the day changes, you have free created partition that will accept this data that is coming. And you don't want to create a table with thousands of partitions, so you want to do that regularly on time. uh, Implement partitioning on the table. So now when you do all these changes and test as a DBA, and you need to inform the development teams that you found some kind of a solution, so they will need to implement some changes on their tables. They will need to have a proper scripts for how to actually do that. We had the situation when we were creating range partitioning for which is actually a point in time. So if we create partitions now on some tables, it will, and say create partitions for the next 30 days, it will create partitions for May, let's say. And if we execute the same statement at September, it should generate partitions for September, not for May. So you cannot put fixed values for the dates there. You need to have a dynamic script that is going to create proper partitions at the moment that it is executed. So the next thing is to define settings table. Settings table is like configuration table. I want to have a single place to have control of everything that my automation is going to do on this system. So I want to have one table in which I'm putting all the settings, like these are the table names, they belong to these schema names. I want to have, I don't know, 10 days of to keep partitions for 10 days for this one. The other one is partitioned by month, so I want to keep 3 months, or everything that is related to the automation should be in one place. And that is the actual input that my automation script needs to work with. And I was thinking what should be the output out of it. So I want my automation to do with this input data, and what should I see in the log, or what should be the actual output out of it. So we will speak about this in details later. Then when you have idea what you want to put in the settings table and what you want as an output, you can create the stored procedure that actually takes this input, do all the logic that is needed to be done to handle the partitions, and provide you with some proper log for future troubleshooting, or just having information what was done and when. Uh, Once we create the stored procedure, then we need to call it. If we need to call it every day, it can be also overwhelming. So in our setup, we decided to use uh, scheduled event for it. So you can schedule it in the scheduled event, or you can execute it manually anytime. So it must work both ways. And if you execute it once in a day and it creates all the partitions for the tables that are defined, if you execute it once again, it should actually not do anything but report that everything that was expected to be done for these partitions is already done. So it should not fail or do some stupidity in the tables. Um, we should create some kind of monitoring, and we were thinking that a monitoring view on the database side would be beneficial to check crucial things, and with simple select statements, and report or generate an error message and a specific status only when we have a problem. Uh, After that, we need to implement alerting on errors. So we would want to be notified on Slack in our situation only when we get an error. So if everything was done correctly, be silent. We we are sure that everything is running okay. And maybe the most important thing at the end, we need to isolate the solution in a separate schema and allow access only for DBS. So when you create something powerful that can change and interact with tables actually owned by different teams, you don't want to give access to that powerful thing to everybody or somebody that is not a DBA and don't understand this. And it should be well separate and isolated in a separate space. So you allow access only for DBS. And why? A simple thing can be, if a developer can go there on production system or staging system and change the value of the sum setting from keep last 30 days to keep 0 days, you will efficiently drop all the data from the table and you will have problems. So you should take care of that also. So how my settings table actually looks like, I will not go into details. This is some example for just a moment, uh, how that looks like. I need to provide some kind of a configuration per table. So in this table, I want to have the option to provide input for multiple tables, and for each of these table, I want to have the full input that I need to give to the automation. So it should be a single place to set up the behavior. So if I open this table with a select, I should see everything related to my automation and understand how it will work in the background. Uh, I should define the range type. On my side, we decided to use day and month partitions only. So I say that, okay, I have this table in this schema. This is the partitioning column, and we want to have a range partitioning type like for day. This means that this number here means number of days, and this means that this number here means number of months. So after that, I define how many partitions I want to retain, how many partitions to add for the future, and what is the actual operation that I want to do with it. So in our situation, we have provided option to drop and to move partitions. If you want to move it, you must provide information where you want to move it. And if you provide that, you need to be sure that this table actually exists and it has exactly the same structure as the previous one, so you can do the thing with the exchange partition. Uh, if so, this was our situation. If in your case you know that you will always work with monthly partitions only, so you don't need to provide this range type, so you can omit it. So you know that all the partitions are monthly. If you have fixed value agreed with the team that you will always create future three future partitions, so you don't need this column. If you agree that you will always drop the old partitions, you don't need the operations column and so on, and you don't need the destination things also. So it depends on how you plan your automation to do the changes, and then you provide the minimum amount of input that is required for this, for that setup. After that, logs table. So how I want to see the things, what was happening. So I, as I said, I want to set it and to forget it. So I will want to check the logs only if something bad happens. So I will not check the logs each day. uh, and the thinking was, I want to see the logs, the actual SQL that was executed on the target tables, and with the intention what this SQL wanted to do. So it should be the same kind of uh, SQL code as if I was doing that manually. So if I was doing that manually, I would want to have some comment in my script that, okay, I'm adding one new partition for this date into this table, and here is the SQL. So how I solve that. And after that, I want to have a comment that I dropped one partition. This was the size at this time, and this is the alter statement. So the uh, stored procedure should generate automatically this kind of SQL statements with all these details. And at the end, if everything was executed correctly, it will store that into the logs table. Um, when we started this solution, we had simple table that was let's say similar to the settings table with few more columns in which we were saving this SQL as a text, and any errors were caught by the stored procedure and put there as text also. But then we had multiple stored procedures on our systems in the same schema, let's say, which were doing different kind of automations for us, and we wanted to centralize the logging into one simple table. And we said, okay, we want to have freedom in uh, the schema of the actual logs that we are generating. So we defined this kind of table, which you see is also partitioned, and it is placed into the settings table for the partition manager to manage those partitions also. So to create new ones and to keep, let's say, last 12 months of data and keep delete older logs. So our main content of the log goes as JSON, and we have something like this, an example. Here is the executed SQL, so what was executed, and we have the execution time and a copy of all the table details that were found in the from the settings table. So we want to have a snapshot in time, which were the settings at the time when this SQL was executed, because it can change. So um, once this is defined, also we said that we can create our stored procedure, and this is not actual code. It is like a pseudo code for how, which are the parts that you should take care of. In our solution, we had this input type that accepts if I wanted to target only daily partition tables, weekly partition tables, monthly or yearly, or maybe all of them from the settings table. So then I declare all the needed variables, declare custom exception for my own errors that from my own checks that I want to have in the code. Declare a cursor for the settings table, and then I'm looping over that the cursor for each row at a time. So working on one table at a time. What is the main goal here? The main goal is that I can use the data, the metadata, which already exist in information schema columns and information schema partitions tables, which will give me all the needed details about what I need to do with the partitions, not without need to actually touch the target tables. So I can plan what needs to be executed on the target table, which exists in the application schema, without ever touching that table. Uh, then I construct automatically the SQL strings that needs to be executed for adding new partitions and dropping or moving old partitions, pack them all into a separate prepare statements, and then execute them, execute those prepare statements one by one. And the output of that must be placed into the common log table to actually make the full cycle of input and output. And in our solution, we had introduced something like defined amount of sleep before uh, next iteration, because we didn't want to overwhelm the system with too much DDL changes in a smaller period of time, because it was really not important if the partition was dropped at 3 o'clock in the morning or at 3 o'clock and 2 seconds. So we can have some pause between those cycles. And yeah, the main things that I wanted to give you as hints: when you're planning this kind of automation, you should always catch logs and errors and warnings, because when you are troubleshooting something, you want to make sure that you have caught everything. So if MySQL was having trouble with something and was complaining with some warnings about your SQL statements that were automatically generated, you want to catch those and log them properly. And if you have errors, you must catch them and have them in the log. Use metadata, as I said, to build the SQL statements. Use prepare statements because it is very powerful. Any string can be executed as a SQL statement in the background. Next thing is focus on your use case. So as I said, if you have a limited amount of all the options that I mentioned, just stick to those. Don't overcomplicate things, because you want a proper solution that works for your production systems and is not rich of features that might or might not need it in the future. So you want to focus on only what is needed. The next hint here is don't overcheck things. Like you're creating your solution on by yourself, and you have the full control out of it. So you don't allow um, non-DBA users to put settings into your settings table. So whatever is written there, you can trust in it. So if somebody declared that this table needs to be partitioned, you don't need to recheck the table name, uh, or if I provided, uh, I declare the future partitions column as not null and it must be positive integer, I don't need to recheck the things in the code. So you want to have simple code in the background and trust in your own setup. Uh, you should balance between dynamic and fixed values. As I said, in our setup, we are providing the partitioning column as fixed value, because we wanted to have a simpler solution. That column can be found by the metadata, as I said, but I will need to provide few additional SQL queries in order to find it. So I don't want to overcomplicate the things, and I trust in my setup. So I just put the string in as a fixed value. Uh, as I said, avoid nice to have features until the first version. So you want to focus on the main goal, and main goal is that you need a reliable solution that can replace you as a DBA to manage these partitions. So you need to make sure that this thing actually works, and this thing can actually manage tens of production systems without you looking at those things every day. And when you provide the first version, then you can think about what is nice to have for the next version, or maybe for some time in future. Test. This is crucial to test all the things, because, as I said, this is a very powerful thing. It can generate any alter table statement and execute it on the system, because you're giving it permission to do that. So you better test it carefully before somebody wakes you at 3 a.m. with an incident and says, we lack 2 months of data on the production database. And you want to ensure that monitoring is in place. As I said, to have a set and forget concept, you must have the monitoring in place to alert you if something bad happens. Uh, the scheduled event is something that we wanted to use in order to simplify the call of this procedure. And it can be simple as this one on the left side, because it works for all the partitions. Uh, it can call always, it can process always all the input from the settings table each day. And if it is not needed to do anything on that table for that day, it will not do anything, so not execute any alter table statements. Or you can complicate it a little bit and provide something like this. So if I have partitions that must be managed on a yearly level, I want to do this once a year, so maybe on the 1st of January. If I have partitions by month, then I need to process them once a month, so not every day, and weekly and daily. So if I execute this every day, I want to manage the partitions, daily partitions every day. Uh, as I said, we wanted to have some monitoring view in order to uh, gather all the, the select statements that we want to execute into one wrapper and to save that code into the database itself, because we wanted to have simple check from the outside system, from the third party system that we use for alerting. So you know, to avoid having 5 or 6 selects copied over and over into multiple tools that are monitoring different environments, you want to have something like this. So select everything from this view, and you have the crucial information provided to you. So if we have an error, it will report like you have one error and this is the error, if you want to show it somewhere, or only this information is enough. Or if everything is good, it will return like status is 0, everything is okay, you can sleep, and that's it. So what you want to check, our thinking was that we want to check the event scheduler, the global variable that controls the scheduler. Why? Because if somebody disables that, nothing will be executed automatically. The same thing applies to the event status. So when I create the scheduled event, somebody can disable it and forget to enable it if there was some maintenance or something. And I want to be notified if that is the reason, because the automation will not run. Uh, I want to check if I have new records in the logs. If I don't have new records in the logs for today, it means that the automation was not run today. So maybe I want to take a look what happened. Then we are checking if we have any errors in the logs for today. So if we have, I don't know, 10 tables, I have 10 records into the error into the logs table. And for each of these records, if there is no error, I'm good. If there is an error, I will want to be alerted about it. Next thing is to check if we have records in PMAX. We want to avoid this because in our systems, it means that if we have records in PMAX, we didn't provide the partitions for those dates on time. So now the system doesn't know where to place those records, and it is placing them into the last partition. So we want to check the system and to manage it before it gets too late. So if you forget or not check this, and you want to check this, and you will understand that you have records into the last partition after 2 months, you might have already terabytes of data into that partition, and it will be a nightmare to split it after that. Uh, yeah, the final thing is you want to check everything that is crucial for you. So you think about what is crucial for my system and I want to be alerted for, and then you provide actual code how to check that. uh, as I said, this concept for us give us the freedom to wrap up everything inside the MySQL. So we keep everything as a code into the database itself. It simplifies checks from the external tools. You give to the external tools read-only access to this view and the underlying table, so it cannot change any data. It just sees that everything is okay. And yeah, you can connect the tools very easy with this concept. Some final takeaways about all the things that I've mentioned here. You should think about partitioning and to understand if it actually helps in for your data model and for your situation. If it doesn't help and give you some benefit, it is just a complication to have it. So you should avoid it. If you decide to implement it, you should implement it very carefully because it becomes very complicated things for management after that. Uh, you need to automate only what you currently need. So don't look 5 years from now to try to plan what will be the changes needed then. So you focus on what you currently need, do the automation, then build your automation with a set and forget concept. So you want to, when you set up these things on one system, you want to forget about it. I was checking yesterday the first environment where we set this up, and it was like for 3 years ago, and we didn't had any problems since then. So it is really a set and forget concept. Uh, Keep it simple and maintainable because you or maybe somebody from your team will need to maintain that thing after some time. And even if you open the code that you wrote 5 years ago, you will not maybe understand what you wanted to do with it. So you want to have it in maintainable form. And again, test. You need to test everything carefully because if you don't test it properly, you will just create problems for you in future as a DBA. And make sure you have all the monitoring in place before you install this thing and put it on production systems, because you want to have proper monitoring from day one. So not install it today, we will monitor it from next week. You will be surprised how much things can go wrong into that time. So if somebody have some questions about anything that I've already said, I'm happy to answer. If not, this is my LinkedIn profile. Let's get in touch. As Igor said, we should keep this user group rolling for the future. Thank you.
Okay. Thank you, everyone, for joining us this evening. And we are starting already to plan our next meetup in about a month. Again, thank you, Oracle, for sponsoring us this evening. And let's have some beer, beverages, maybe, and some pizza. Thank you.